So these ones that are expand and simplify, right? I see that exponent of 3. I know there's going to be 4 terms. So I'm going to go to Pascal's triangle. Don't have to go very far until I get 4 terms. Write out my numbers 1, 3, 3, 1. We're going to start with the 4a squared 3 times. Then we're going to have the 4a squared 2 times and the 2b once. Then we're going to have the 4a squared 1 time and the 2b twice. And finally, we're going to have the 2b 3 times. So we use Pascal's triangle to get the blue numbers. And then we use the pattern with exponents to write the other.
Happy New Year.
Happy New Year. From here, we can just do order of operations. So 4 cubed is 64. A squared cubed, oh, we have to know our exponent rules. Is that a to the 5 or a to the 6? 6. A to the 6. Good job. Plus 3. If I square, this is going to be 16a to the 4. Still have a 2b. So I'm just doing my exponents. So 4b squared. Careful, 2 cubed is not 6. So I just did my exponents first. And now I can put my numbers together. So this is going to be 64a to the 6, nothing more to do there. 3 times 16 is 48 times 2 is 96, and I have an a to the 4 and a b. 16 times 3 is 48, and I have a squared, b squared, and finally the 8b cubed. Here is my final simplified answer. And this is significantly quicker, right? What we're doing right now is seeing that we've recognized a pattern, and using that pattern has allowed us to multiply this out hopefully in a quicker way than what we would have used to have to do. We'd have to FOIL the first 2 together, get an answer. And then once we get that answer, multiply it by the next one, combine all those like terms and get an answer. That's not wrong. You could still do that way. But this is significantly quicker, especially when the exponents get bigger and bigger and bigger. It's still not, like look at the math that we had to write down. There's still a lot to write. And it's quite involved, but it is quite a bit quicker. You can circle question 7. And then just at the bottom of page 741, at the bottom of this question, or maybe I even have it here. I'll go. Okay. The general term or kth term in the expansion is, and your formula sheet doesn't do it for the kth term, it does it for the k plus 1th term. So again, on your formula sheet, they have for a plus b to the n, term k plus 1 is n choose. And the reason the formula sheet does k plus 1 is it just makes the formula actually a little bit nicer. So by doing k plus 1 here, this is just a k instead of a k minus 1. And then this just becomes n minus k and b to the k. And what that's going to allow us to do is figure out specific terms if you don't want to find them all. Okay? It's also going to allow us to do, and I'm going to turn back to example 2 here for a second and show you. Let's say you just wanted to find this one, term 2. And now, I could find all 4 of these with the formula instead of doing Pascal's triangle. I'm going to tell you if you have to find them all, Pascal's triangle is probably the quickest. But you don't have to. You could use the formula. So I'm going to write out the formula here from your formula sheet. K plus 1 is n choose k, a to the n minus k, b to the k. And if you wanted to find term 2, can you see that if you wanted to find term 2, what would k have to be? K would have to be 1, because 1 plus 1 is 2. N is your exponent. Your exponent here was a 3, so I'm going to have a 3 choose 1. Multiplied by, well, what a is your first term was a 4a squared to the exponent of 3 minus 1. And your b is your second term, which is 2b to the exponent of 1. Notice that using the formula, the 3 choose 1 gives us the 3 that's right there. Here I'm going to have 4a squared squared. Do you see that that matches up with that? 4a squared squared, so this will be 16a to the 4, and 2b to the 1 is 2b. Well, then it's leading me right down this path to get that second term. The formula you could use to find all 4 of those, you would just have to do the formula 4 times. That would work as well. What we're going to do in tomorrow's class, and if you look at example 3 has something to the power of 10. That would have 11 terms. But instead of finding all 11 of them, it just says, hey, just find the 9th one. Tell me what the 9th one is. Then the formula makes a lot more sense.